She got it from the lunchroom.
All right, here we go. I don't feel good, so let's get this done.
Sorry.
Like, I don't feel good, like I might not be here tomorrow.
Hey.
Be here tomorrow? I don't
Sometimes.
know. We'll
Do you want
see.
Advil?
I already took some.
Okay.
Maybe.
Off the record? Like not on the recording? Can we delete this one real quick? On the record.
Friday.
Yeah,
You
yeah.
still
Gotta go.
don't feel too good. You can stay home Friday too. No, just
In the
relax.
event that I'm not here tomorrow, I will post a video and you can watch the video
Nice.
on the class website.
I miss you.
All right. Do I need to say anything here? I don't think so. Okay. So applications and models. We're doing some word problems today. Some applications or fun little joke worksheets again. And these are applications. We've done some applications before where we're using the trig function SOHCAHTOA to set up trig little equations and solve them. So we've done that. Doing basically the same thing today, except we're going to be utilizing the inverse function to find the angle measures. And so that's how this ties in. We've been doing inverses, and so you'll see some inverse problems here today. So example 1, find the side or angle labeled. So one worksheet is like this, where they'll have the little angle marked, and that's the letter that you're trying to find to place in the puzzle, all right? And so look for that little indication marking. That's the angle we want to find. This one is just to remind you that we've done this before. So this is how we set things up. And I went back to some sort of old school triangle notation. So just to refresh your brains, I'll talk about that in just a second. So find the side or angle labeled. All right, so it's customary when we're dealing with right triangles, we use, well, really any polygon. To represent the vertices, we use capital letters. So you can see capital A, B, and C. And it's pretty customary that C is the right angle, but it's not always the case. It should be labeled, and we just use capital letters. Now, what is customary is that whatever side is opposite that labeled angle. So if we have capital A for this angle right here, its opposite side gets a little lowercase a. So every opposite side uses the lowercase letter. So this angle B here, opposite angle B is side B, and we know that that's 19.4 units, whatever those units happen to be. And they're also telling me that angle A is 34.2 degrees. So I'm going to label that 34.2 degrees. What mode should your calculator be in? Degree mode. So you definitely want to make sure that your calculator is in the proper mode. So mine is. And if you have a Casio, let me know. You can go to setup. Setup to change from radians to degrees. All right, and so now I'm trying to find this side over here, which I indicated with a question mark, and I guess we'll just find C. Well, that's going to be little c, just so that's opposite big angle C. We're going to find little c. So this is the side we're trying to find. And so what I'm going to look at is what information they've given me. I have my angle measure, very important angle. And if that's the angle, then this would be the adjacent side, and C would be the hypotenuse. And since I have adjacent and hypotenuse, which trig function can I write? Cosine, yeah. So cosine of 34.2 degrees equals adjacent over hypotenuse, so 19.4 over C. And how do I solve for C?
Multiply it.
Divide.
Multiply that C first.
Whoa, I gotta multiply the
We
C.
skipping
over.
steps now.
Yeah, oh, you guys are ahead of me.
skipping.
I see. This is C times the cosine. cosine of 34.2 degrees. I understand what you said now. There's that was, yeah, I'm slow. So, oh God, see, and I keep writing 2's instead of what I'm doing. All right, so I multiplied c to the other side, and then we can divide by the cosine of 34.2. So 19.4 divided by the cosine of 34.2 degrees. You can see they just sort of did trade places. And we type that in. 19.4 divided by the cosine of 34.2 degrees. 23.46 maybe? I don't know. 23.46. I think whatever those units happen to be, that is a length unit. I think on your worksheet today, the first one, we're finding angle measures, and they'll actually tell you around to the nearest whole degree. So that's kind of nice. Okay. Over here, we have triangle ABC. Side B is 16, so that little b over here is 16. And side C is 32, so little c is 32. And we're trying to find angle B right here. This is the marking you'll see on your little worksheet today. And so if this is my angle, then 16 would be called the opposite side, and 32 is the hypotenuse. And so which trig function could we write? Sine of angle B is opposite over hypotenuse. So 16 over 32. Now, we're trying to solve for angle B. Well, right now, angle B is trapped inside a sine function. Sine is not a number. You can't just divide by sine. It doesn't work that way. It's an entire function. And so to cancel out the sine, to get rid of it, so B is by itself, we're going to use sine inverse of both sides. Sine inverse and sine undo one another. They're inverse functions. They cancel one another out. That was the entire purpose of our inverse functions. This is why. Okay, so they can undo one another, and then what I'm left with is angle B is the sine inverse of 16 over 32, which reduces, but doesn't matter. And again, we want to be in degree mode because we want our answers to come out in degrees. So I'm going to go ahead and type in sine inverse. So make sure you use your inverse function of 16 over 32. And it turns out that angle B is 30 degrees, which I knew because this was 1 and 2. That's good. Short side, hypotenuse. That's a 1 radical 3, 2 triangle. But that's me. All right. So you're going to do this a lot today where you have to use an inverse function to get the angle by itself. Okay, to solve for the angle. Any questions on that? All right, that's the whole point of inverse function, so we can solve for the angle measure. All right, is that it? Let's just do this last one. You can just draw the picture if you would like.
Oh, I can't do that.
It doesn't. It really just needs to be a triangle. I know. That's why we're doing it, just because it's got some fancy clip art. We all live in a yellow submarine. Example 2. A sonar operator in a ship detects a submarine a distance of 400 meters. So the sonar operator is sitting here in the ship, and he's detecting this submarine 400 meters away at an angle of depression of 35 degrees. Tell me something interesting about angles of depression. They go down from what? From eye line, from eye level, or from horizontal. Remember that whole discussion about keep your eyes up, look straight ahead? T-A-L, horizontal. Okay. So anytime you see angle of depression or angle of elevation, that's always from horizontal. So this is from horizontal, this horizontal water line down is 35 degrees. And we want to know how deep is the submarine. So we want to find this depth here. So with my picture properly labeled, I have the opposite side and my hypotenuse. So which trig function can we write?
Sin.
Sine. It's not a sin. It is sine. Sine of 35 is opposite over hypotenuse. You will have a mixture today of problems where they're going to be easy to solve like this one, or ones where you might have to use an inverse function to find the angle measure. So pay attention. How do we get d by itself?
Multiply by 400.
Multiply by 400. So 400 times the sine of 35 degrees is our depth. 400 times the sine of 35 degrees gives me 229.4 meters deep. All right. So if you're trying to find an angle measure, then you're going to have to use an inverse function. Do you have any questions? Super.